Okay, number 9 is the next one. Number 9 says we have an Andrew, who is our quarterback. He's running forward at 3 meters per second. So the mass of Andrew is given to us as 50 kilograms. And the speed of Andrew is 3 meters per second. And he runs into the back of Mike. And Mike is the 95 kilogram linebacker. And Mike was moving, at the time he was hit, was moving at 8 meters per second in the same direction. As a result of this collision, we figure out that Mike is now going to be going 1.25 meters per second. And we want to know the new speed of Andrew. So MAVA plus MBM, oops, that's supposed to be an M, equals MAVA prime plus mass of Mike, speed of Mike prime. So this is 50 times 3 meters per second plus the mass of Mike is 95 kilograms times 8 meters per second is equal to the mass of Andrew, which is still 50 kilograms, times the new speed of Andrew, plus the mass of Mike, which is 95 kilograms, times the speed of Mike after the collision, 1.25 meters per second. So I did the math and I got VA prime, the speed of Andrew after all this, to be 15.825. Yeah, 15.825. So I could not find any mistakes to tell me why my answer didn't match the correct answer at the bottom. Maybe you can figure it out and let me know. I would appreciate it. Okay, number 10, you have a physics teacher shoots a rifle at a block of wood. And the gun is going to fire a bullet with a speed. What is the velocity of the gun, or the block of the wood with the bullet inside, and what is the recoil velocity of the gun? So I said, okay, well, let me get everything set up. So the mass of the block was 0.50 kilograms. The mass of the gun was 8 kilograms. The mass of the bullet was 0.025 kilograms. And we knew the speed of the bullet was 250 meters per second. So we needed to find the speed of the block and the bullet. And I'm going to call it prime because that's after the bullet lodges in the block. And then we wanted to know the recoil speed of the gun. Okay. So I did two separate things. I said M1V1 plus M2V2 equals M1 plus M2, because they're stuck together now, V prime. And I said that this would be the block, and it wasn't moving. So that gave me a 0.025 kilogram bullet, moving at 250 meters per second. And then the block and the bullet together were 0.525 kilograms times their new common velocity, V prime. So when I did that, I solved for V prime, and I got 11.9 meters per second. And then I did the gun. So I said M1V1 plus M2V2 equals M1V1 prime plus M2V2 prime. And before the bullet was fired, the gun was not moving. The bullet was not moving, so the whole left-hand side goes to 0. So I'm going to let this be the 8 kilogram gun, recoiling backwards at some speed. And then the bullet is going to be 0.025 kilograms. And I'm going to let its velocity be a negative 250, because it's going to head in a direction opposite the gun. So when I solved for that, I got the speed of the gun, the recoil velocity of the gun, to be 0.78125. meters per second. All right. Now we're on to number 11. So 11 is the one, I believe there's a vase and a soccer ball in a house. Yes. So I said that the mass of the vase was 1 kilogram. The mass of the ball was 0.25 kilograms. The speed of the ball, I made it negative. And the speed of the vase after, that's after. The speed of the vase after the collision was a positive 2.3. So I believe they're asking you to find the speed of the ball that Amanda kicks it with before it hits the vase. So M1V1, M2V2 equals M1V1 prime, M2V2 prime. So M1V1 is going to be, let's let that be the vase. It's not moving. So she kicks the soccer ball with some speed that we don't know. And as a result, she has the 1 kilogram vase moving at 2.3 meters per second, plus the soccer ball bounces back at her. So I made that a negative 3.5. So when I did all that math and solved for my V2, I got 5.7. And that would be the speed of the ball as she kicked it toward the vase. And then it wanted to know, for the second part, if the soccer ball had come to rest when it hit the vase, what would be the velocity of the base? So M1V1 plus M2V2 is equal to M1V1 prime plus M2V2 prime. So I said, well, that's the vase. When it was just sitting there, that's the soccer ball coming to rest right there. So I had 0.25 kilograms. And I'm going to assume that she kicks it at 5.7 meters per second. And then I'm going to have a 1 kilogram vase. It's going to fly off with some speed that I'm going to call V1 prime. And when I did that, I got V1 prime to be 1.425 meters per second. Okay. That leaves me number 12 and 13. Oops. Sorry. Let's do 12 first, and then we'll come back to 13. So 12 said that we had an astronaut is sent to repair a 800 kilogram shuttle. So the mass of the shuttle is 800 kilograms. The mass of the astronaut and the vehicle that he's in, which is called an MMU, I think it is. Yes. The mass of the MMU is 500 kilograms. The speed of the shuttle is 18,000 meters per... Nope, that's not true. The speed of the shuttle... Yes. Satellite, the speed of the satellite is 18,000 meters per second. And the velocity of the MMU is equal to 19,000 meters per second. So I said M1V1 plus M2V2 is equal to their combined mass, because the astronaut hooks up with the satellite, times their new common velocity. So I said that 800 kilograms times 18,000 meters per second plus 500 kilograms times 19,000 meters per second is equal to 1,300 kilograms, because that's the total mass, times their new common velocity V prime. And when I did that, I got V prime to be 18,385 meters per second. Okay, number 13 is my last one. I believe it has an angle. So I said ball A comes in like that, hits a stationary ball B. They bounce off at a right angle. So I said that this would be VA prime, because it tells me that it goes at 30 degrees to the left of the original direction, so that would be VA prime. And VB prime tells me it goes to the right of the original direction, 60 degrees. So I separated into the x-axis and the y-axis. I always solve for my y-axis first, because that's how I find the relationship between VA prime and VB prime, because if you look at before the collision, there is no y motion. So MAVA plus MB VB is going to equal MA VA y prime, and these should have been y's here, minus MB VB y prime. And this negative sign tells me that it's headed in a direction opposite of A. There's nothing on the y-axis prior to the collision, so that whole thing goes to 0. And I know that the mass of A is 5 kilograms. And the y component is going to be the sine of 60 degrees times VA prime. I'm sorry, let me fix that. It should have been the sine of 30 degrees because A was the 30. Times VA prime minus 2.5 kilograms times the sine of 60 times VB prime. So I found out when I did the math that VB prime was equal to 1.155 VA prime. So now I'm going to use that information and go up and do my x-axis. So I have MAVAX plus MBVBX equals MAVAX prime plus MBVBX prime. This is 0. So I have mass of A is 5 kilograms, and it's moving in at 5 meters per second. That gives me 5 kilograms. And that's going to be the cosine of 30 degrees, VA prime. And then I have mass of B is 2.5 kilograms. And VB prime, or VBX prime, is going to be the cosine of 60 degrees times VB prime. But I know that VB prime is the same thing as 1.155 VA prime. Okay, I need to check my math, and yep, that's good. And this is just a substitution that I can make in there. So then I did my math and I solved for VA prime. And when I did it, I got VA prime to be 4.33 meters per second. And then I got VB prime is 1.155 times 4.33. And VB prime was 5 meters per second. All right, please study.